The moon, an 81 million billion ton lump of rock and dust, more than 2,100 miles in diameter, orbiting almost 250,000 miles above our heads. It is the second brightest object in our skies, with temperatures ranging from 250 degrees down to minus 380 degrees and lower. Its gravity is a sixth of that of Earth. Mountains soar to 16,000 feet, and millions of craters litter the dust-dry surface, where no liquid water has ever been found. This is not a hospitable place. And yet, we associate the moon with romance and mystery. The man in the moon enraptures lovers all over the world and feeds our hunger for supernatural myths and legends. We are far from alone in having a moon. There are at least 135 other moons orbiting the planets in our solar system. Saturn has the most with 46. While we have at least 10 mysterious bodies orbiting our planet. 5 are asteroids caught temporarily by the Earth's gravitational field, and 4 are probably remnants of the Apollo 12 rocket. The 10th and largest is our moon. Since long before the birth of humankind, the moon has been the Earth's constant companion. But until relatively recently, we've known little of its true nature, or even how it was created. There are several competing theories. One suggests that the moon is merely an asteroid or planet trapped by the Earth's gravity. Another ascribes the creation to a giant impact on Earth, ejecting masses of material that formed the moon. Clues as to which theory is more likely to be correct came when men first landed on the moon and started unlocking the secrets of creation buried within the lunar rocks.
5, 4, 3, 2, 1, 0. Liftoff. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Between 1969 and 1972, 6 missions blasted off to the moon.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal.
Only 12 humans have ever walked on the moon. But these astronauts did more than just rewrite history. They also returned with samples of lunar rock. These moon rocks are amazingly similar to Earth rocks, but they contain far less iron. This seemingly small difference offers a huge clue as to how the moon was created. It shows that the moon started with a bang. Let's step back 4.5 billion years in Earth's history. The moon does not yet exist. The inner solar system has about twice as many planets as the 4 that exist today. Many of them are on a crash course to destruction. Among them is a planet about half the size of Earth, since named Theia, who in Greek mythology was the goddess mother of the moon. The 2 bodies are on a collision course. Inexorably, Theia rushes closer and closer to Earth. The approaching planet is a terrifying sight. Astrophysicist Jeff Taylor studies the moon's fiery birth. He describes the view from Earth as Theia races toward it.
It might have started looking like a star, or a pretty big star, but then as it got closer and closer, this thing would get bigger and bigger and bigger and bigger and bigger until it just filled the sky moments before the big impact. And then everything would be would be gone for you as a witness, and there would be a giant flash because everything would be white hot. And if you were standing, or a friend of yours, on the other side of the Earth, they would see the flash in the atmosphere and feel gigantic earthquakes passing through the Earth.
Theia is 4,000 miles in diameter. To put its size in perspective, the meteorite thought to have wiped out the dinosaurs was about 6 miles across. Theia is traveling at 25,000 miles per hour. That's about 20 times faster than a supersonic jet.
This is an object that is the size of Mars, which is about half of the Earth's diameter. So it's a gigantic event of unimaginable power.
As the planets get closer, their immense gravitational fields rip each other's outer layers to pieces. Then, they catastrophically collide. The impact is equivalent to billions of megaton bombs. The impact shears off continent-sized sections of the Earth's crust, blasting surface rocks out into space. These surface rocks contain only a small amount of iron. The atmosphere around the molten planet is filled with rock vapor. Earth's gravity pulls back most of the debris, but some is catapulted into space, although it cannot escape completely. Instead, it is trapped by the Earth's gravity, forming a ring of red-hot dust and rock around the planet. In a process called accretion, the circling dust and rocks collide and fuse with other fragments to create larger blocks.
We can represent this process by olive oil and water. The water here represents the space around the Earth, and the olive oil is the debris thrown around the Earth by this giant impact. And each little droplet that we pour in here represents a given chunk of matter thrown up, blasted off the Earth. We're going to stir this around, indicating the way the debris is being moved around the Earth.
But when Taylor stops stirring, the drops bump into each other and clump together as bigger droplets.
And that process of small things bumping into each other, becoming larger, is called accretion. And that's how the moon formed around the Earth. It's how the Earth formed around the sun.
As the debris clumps together, its combined gravity becomes strong enough to attract even more debris. This chain reaction doesn't stop until the billions of fragments of vaporized rock have gathered into one red-hot ball of matter. In less than 100 years, this cools into a solid lump of rock, 1/50th the volume of Earth. It becomes the moon. When the moon forms, it is just 17,000 miles away, but it doesn't stay as close as that. Its violent birth sets it spinning away from us on a journey that will last for 10 billion years. Absolute proof that the moon is moving away comes in 1969, when astronauts leave an 18-inch reflective plate on the moon's surface. By bouncing lasers off this plate, scientists can pinpoint the moon's distance from Earth to within an inch. Such calculations reveal that the moon is moving away from Earth at a rate of about 1.5 inches per year. So why is the moon on the move? In the 1990s, supercomputers gave scientists a more accurate picture of what happened 4.5 billion years ago. Computer models of the creation impact reveal that the collision of Theia and Earth is a glancing blow. It imparts a rotational force to the Earth. This rotation gives Earth its days and nights. But the huge power of the collision sets the Earth spinning far faster than the moon, which orbits around it. In these early days, Earth spins once every 6 hours, 4 times faster than today, whereas the Moon takes 20 days to complete one orbit. So the Moon orbits more slowly than the Earth spins. However, the early Moon is 15 times closer than today, which makes the effect of its gravity so strong that, as this graphic demonstrates, it pulls up a bulge on the Earth's surface directly below it. This bulge moves like a tide across the Earth's surface with its own gravity tugging on the Moon. Because the Earth spins faster than its satellite, the bulge is always ahead of the Moon. So it constantly pulls the Moon forward, causing it to accelerate. Any object that travels in a circular motion will move outwards as it accelerates, much like a hammer being thrown in the Olympics. As the Moon accelerates in its orbit, it starts to spiral away from Earth. It's a journey that will continue for billions of years. At the time of its birth, the Moon orbits Earth 15 times more closely than today. But this close proximity puts the Moon in great jeopardy. It faces a bombardment by thousands of asteroids, which will destroy 80% of its surface. It is now 4 billion years ago, a time the scientists call 4 giga-years ago, or GYA. The Moon now orbits 86,000 miles away, still 3 times closer to the Earth than it is today. From our planet, the Moon dwarfs everything in the sky. During this early period of its life, the Moon has its most profound effects on Earth. The massive collision that creates the Moon is so powerful that it knocks the Earth off balance onto an axis of 23.5 degrees. It's this tilt that gives us our spring, summer, fall, and winter. If we spun on a vertical axis, like the planet Mercury, seasons would not exist. Everywhere would receive 12 hours of light and 12 hours of darkness. The poles would be entombed in an eternal freezing twilight, while the equator would bake in endless heat. But the Moon does more than merely produce this tilt. It also maintains it. The strong gravitational pull of our young Moon acts as a global gyroscope, stabilizing the Earth's axis. Astrobiologist Lynn Rothschild explains.
The reason we have this obliquity that holds steady is because the Moon helps to stabilize the obliquity of the Earth. If we had no Moon, we would end up with what the astronomers call a chaotic obliquity. We'd have quite a big shift and fairly low timescales.
Without our global stabilizer, our axis could vary between 0 and 90 degrees. This would alter the distribution of sunlight across the surface of the planet, devastating our finely balanced weather systems. Climate patterns would go berserk. The tropics could find themselves frozen under ice, and Antarctica transformed into a vast desert. But luckily, the Moon saves us from such disasters and allows life to exist.
It turns out that it may have had a really profound influence on how life has originated and evolved on the Earth. In fact, you might almost be able to argue that we wouldn't be here today filming this if the Moon weren't up in the sky.
Not all planets in our solar system are so lucky. Mars has 2 moons, but they are too small to stabilize its tilt. As a result, the red planet rolls much more than Earth. Some scientists believe that this is one of the reasons that there is no life there now. When you look at our moon today, the first things you notice are the craters. They tell astrophysicists, such as David Kring, about a distant and violent past.
You can look up from your own backyard and see impact craters on the lunar surface. There are over 300,000 craters, half a mile to over 500 miles in diameter on the lunar surface.
Most of these craters come from meteorites hitting the moon. The largest crater you can see from our planet is the Imbrium Basin. It is 700 miles across. Moon craters come in various sizes, but almost all were created at around the same time. Around 4 billion years ago, a chance alignment of the gas giants Jupiter and Saturn changes the shape of their orbits. This creates a slingshot effect, hurling asteroids toward the inner solar system, straight at Earth and the young moon. For millions of years, asteroids bombard the entire inner solar system.
Some of these impact events would have produced impact craters the size of continents or larger. These type of impact events have the capacity to obliterate any oceans on the surface of the planet and superheat the atmospheres. Life as we know it could not persist on the surface of the Earth.
This period of intense bombardment is called the lunar cataclysm. The Earth's gravity makes it worse, pulling meteorites and asteroids directly toward itself. On its own, the tiny moon might have escaped with less damage, but it's too close to Earth. Asteroids heading for impact with Earth hit the moon instead. The moon becomes the first victim of collateral damage. Most of the craters on the moon formed during the lunar cataclysm. 80% of the lunar surface is destroyed. Molten basalt oozes from fissures and fills impact craters, creating seas of lava. Over millions of years, these will cool, solidify, and turn into maria, or seas, such as the Sea of Tranquility. It is the pattern of dark basalt rock that creates the face of the man in the moon as we know it today. David Kring demonstrates exactly what happens to the surface of the moon when a meteorite strikes. He releases a 5-pound rock from 50 feet above a sand pit. On impact, sand is fired upwards into the air. During the lunar cataclysm, some impacts are so big that material fired upwards never returns to the moon's surface. Instead, it is propelled into space, where it is trapped by the gravity of the Earth, still only 86,000 miles away. Some of these rocks hurtle toward our planet.
You actually would have seen a huge plume of debris rise up off the lunar surface. This cloud, in fact, would have enveloped the entire lunar surface, and out of that cloud there would have been fragments of rock that pelted the Earth. They would have streamed through the atmosphere as intense fireballs to land rocky components on the Earth's surface.
These lunar meteorites are incredibly rare. This is part of one of only 30 lunar meteorites ever found.
So this is a sample that fell in Africa. Analyses of samples like this tell us that there was a cataclysmic spike in the number of impact events that affected the moon 3.9 to 4 billion years ago.
Lunar meteorites contain a record of the geological history of the inner solar system as it was around 4 billion years ago. These rocks are older than the oldest rocks on Earth. The existence of lunar meteorites on Earth started scientists wondering if rocks can be catapulted from the moon to Earth, could rocks from the Earth also reach the moon? And if such Earth meteorites could be found, might they hold fascinating clues to what was happening on Earth billions of years ago? To blast anything free from Earth's strong gravity requires immense force. Far more power than it takes to launch a lunar meteorite off the surface of the moon. For example, the space shuttle uses 15 million horsepower to escape from Earth's gravity. The lunar module needed just 6,300 horsepower to lift off from the moon. But just how big an impact would it take to blast debris off of the Earth? Award-winning astrophysicist Guillermo Gonzalez from Iowa State University has figured out the answer to that question.
The crater in northern Arizona, meteor crater, even that, which is really big when you go right up to it, wasn't large enough to catapult any significant amount of material beyond Earth's atmosphere. But when you're talking about, say, the crater that killed the dinosaurs in Mexico, now that one was probably big enough to start launching some at least small amount of material beyond the Earth and have some of it land on the moon.
Impacts on Earth during the lunar cataclysm are far bigger than the dinosaur extinction event. They impact with such power that they punch holes in the Earth's atmosphere. Rocks and debris thrown skywards escape through these holes. Once in space, some of the debris is vacuumed up by the moon, orbiting just 86,000 miles away.
And it eventually makes its way to the moon, where it lands. And then when it lands on the moon, of course, it could be further broken up into smaller pieces depending on how fast it hits the surface.
Landing on the lunar surface, they remain perfectly preserved in the vacuum of space.
The early Earth, unfortunately, erased its early history, but it left a record of it, at least a partial record of itself, on the moon. And if we can find some fossils or at least remnants of early life in these Earth rocks on the moon, that can help us answer these difficult questions about the origin of life.
Gonzalez believes that more than 1,000 pounds of Earth rock could be spread over every square mile of the moon's surface.
It's the only place in the solar system that we can go to learn about the origin of life, because once the Earth rocks get to the moon, they're preserved there in a pristine form. There's no water cycle on the moon, there's no more active geology, and they get buried relatively quickly from the material from other impacts on the moon. And so they're preserved from the solar wind and other things as well.
So far, no Earth rocks have been found on the moon. Gonzalez will have to wait until the next moon mission, in the hope that these priceless rocks may then be discovered. The first 500 million years of the moon's journey from Earth has been a violent one. Over the next billion years, the moon continues its escape from Earth and out into space. Its passage changes the face of our planet beyond all recognition. The power of its gravity creates tides thousands of feet high, stirring up the oceans of the Earth. This creates the conditions for complex chemical compounds to form. The moon is aiding the creation of life on Earth. 3 billion years ago, the moon is still escaping from the Earth, and it now orbits almost 200,000 miles away. The effect of its gravity is weaker, but it still has the power to radically change our planet. For now, the Earth has water and oceans, and the moon is stirring things up. It's too far away to have a dramatic effect on the rocks of the Earth, but the moon is affecting the oceans. As the moon passes overhead, its gravity creates tides in the water. But these are not like the tides of today. These are thousands of feet high. Astronomer Neil Cummins studies how the early moon affected the tides.
When the moon first formed, the tides were something like 1,000 times higher than they are today. They would have gone inland as a wall of water, 10,000 feet high as a huge mountain. They probably would have covered hundreds of miles. And then they would come back, scouring the land, taking debris from the surface of the Earth into the oceans.
The material sucked into the seas contains minerals and nutrients. The tides created by the moon churn these into the most crucial cocktail in the history of Earth, the primordial soup. Different combinations of minerals are bound together and torn apart. It's in this violent melting pot that the right combination of minerals is forged into life. Cummins believes that the spark of life might never have occurred without the moon's power to churn up the primordial soup.
The moon created those tremendously high tides back when it first formed that allowed the oceans to fill with minerals, that allowed life to evolve, that allowed us to be here.
The tides may have even helped the first DNA to evolve. Some scientists believe that the changes in chemical concentrations when the tides go in and out cause the DNA to split and replicate. The enormous moon-induced tides have a further vital role to play in the history of the Earth. They help the whole atmosphere of the planet to calm down and become a more hospitable place in which more complex life can evolve. In our look back to 3 billion years ago, the Earth is a very different place. The impact that creates the moon sets the Earth spinning faster. It spins so much faster than it does now that a day lasts just 6 hours. This high-speed spin has devastating effects right around the Earth. The rotation of our planet is one of the most influential factors determining global climate. The spin of the planet creates winds and vortices in the atmosphere. The faster the spin, the faster and more violent the winds. Billions of years ago, when our planet rotated 4 times faster, the atmosphere whips over the land.
When a hurricane occurs today, 100-mile-an-hour winds, trees are blown over, houses lose their roofs, tremendous amount of flooding. But in a day or two, it's gone. Things settle back to normal, people get on with their lives. Imagine if we lived on a world in which those kinds of winds were continuous.
This is the climate of our fast-spinning early Earth. A place with constant hurricane-force winds and giant 10,000-foot tides. This is far too hostile a climate for life to evolve into more complex forms. But the devastating tides that the moon is creating begin to pacify the hellish climate. The tides affect the speed of rotation of our planet, eventually lengthening a day from 6 to 24 hours.
I want to show you how the moon has slowed the Earth's rotation from 6 hours to 24 hours. I'm going to do that with this globe here representing the Earth, of course, and this lens representing the moon. Ruth is going to be the moon. Okay, so here's the Earth going around much faster than the moon orbiting the Earth. Today, of course, the Earth goes around once every 24 hours, and the moon goes around us about once every 28 days or so. Now, the moon creates the tides. The high tide, or one of the high tides, is almost directly underneath the moon. So, for example, there would be a high tide right here, created by the moon.
The moon lags slightly behind these tides because it orbits more slowly than the Earth spins. The moon's gravity pulls back on these tidal bulges, creating drag that slows the spin of the Earth.
And as the water hits the continents and islands and other nasty things in the way, the friction between them slows the Earth down from the 6-hour day to a 24-hour day.
As the Earth's rotation slows, the atmosphere ceases to whip around the globe. Hurricane-strength winds are no longer the norm, and more complex life forms evolve in the relative peace and calm of our planet.
I really think that we owe the moon our existence today. Without it, the world would have evolved differently, and as a result, we would have evolved differently. We would not be the creatures we are.
The power of the nearby moon has dramatically reshaped our planet. Over the next 3 billion years, the moon continues its journey out into space. The moon's influence has waned, but hasn't disappeared. Some scientists believe it causes earthquakes and volcanic eruptions, while many laymen still believe that the full moon affects our human behavior in bizarre and inexplicable ways. Today, the moon orbits Earth 250,000 miles away. It's 15 times further from Earth than when it first formed. It appears as a distant and mystical object in the sky, and its gravitational pull is far weaker than it used to be. The moon's gravity is now so small that it exerts the same upwards pull as a pea held about 20 inches above your head. But some people still believe that even this weak power from the moon affects human behavior. The moon's 29-day orbit around the Earth is called the lunar cycle. During the lunar cycle, the appearance of the moon changes because it is constantly moving relative to the sun and Earth. Volcanologist Steve O'Mara thinks this changing sun-moon alignment is critical.
I'm going to demonstrate to you how the moon goes through its lunar cycle. The volleyball is the moon, I am the Earth. Now the first thing you should know is that the moon goes around the Earth in about a month. Now we're going to start off at this position here, which is where the moon is directly between the Earth and the sun. This is new moon. When I look at the moon, I see it totally in shadow. Now, as the moon moves in its orbit, you can start to see that part of its disk becomes slightly illuminated, and it forms a crescent. This is the crescent phase. As the moon moves further, you see it in a half phase. When it's totally opposite the sun in our sky, here we have full moon. All of the moon is visible, fully illuminated. Now, as the moon continues in its orbit, we see the shadow returning and the phase is diminishing. This is the waning moon. Now we have a waning crescent, and finally we return about a month later back to new moon, and the cycle starts all over again.
The full moon has long been associated with mystery, aggression, and horror. Studies show that the behavior of some animals changes during the lunar cycle. Some creatures' whole breeding cycle is dictated by the moon. Scientists have investigated the link between predation and the full moon. Researchers think that the increased moonlight helps some nocturnal hunters track and kill their prey, although the idea that wolves howl more often on a full moon is nothing more than a myth. Yet, if some mammals do become more active at full moon, might this aggressive lunar trait extend to humans? The streets of San Francisco. Officers Healy and Mahoney of the San Francisco Police Department gear up for another night patrolling the town. They have been policing the tough Tenderloin district for the past 10 years. But this is no ordinary night. It's a full moon. And on a full moon, things definitely feel a bit hotter.
I think some of the clientele we deal with, they think it's a full moon every day, I think, but there's a noticeable difference. You could pretty much ask anybody who works in, service jobs like police, fire, paramedics, hospital workers. They'll all tell you that during the times of the full moon, business just goes up.
But is there any scientific evidence of human behavior being affected by the moon? In 1976, the American Journal of Psychology studied 34,318 crimes and found they occurred more frequently at full moon. A year later, researchers studying 18,495 psychiatric patients found that hospital admissions peaked during a new moon. However, a series of more recent studies reveals no link between human behavior and the lunar cycle. And yet many people still believe in the power of the full moon, possibly because of horror movies and folklore. For generations, we have been led to believe that murder, death, and even mythical creatures such as werewolves are linked to the full moon. It's not surprising that over time, we start to believe the link is true. And the myth of the full moon is kept alive. The effects of the moon on humans may be minimal, but some scientists believe that its gravity still exerts a major influence on the planet itself. It's not only the moon's appearance that alters with the lunar cycle. Its gravitational pull varies as well. At new moon, when the sun and moon are aligned, their combined gravity tugs even more than usual on the Earth. As the moon makes its way around the Earth, it pulls us in different directions. When there is a full moon, the sun and moon pull in opposite directions, in a kind of astronomical tug-of-war. For most of the lunar cycle, there is no danger for Earth. But when the sun and moon are aligned, their combined gravity creates the maximum stress on the Earth's crust. Some scientists suggest that this can trigger devastating natural phenomena. Volcanologists Steve and Donna O'Meara use this cycle to help them predict eruptions. While other scientists check sulfur levels and study seismographic data to predict eruptions, Steve and Donna plot the position of the moon, which they believe has the power to trigger eruptions at certain points in its orbit. The O'Mearas believe that in the complicated cycle of tugs and pulls from the sun and moon, increased stress can distort molten rock under the Earth. At the crust's most unstable points, where volcanoes form, the pressure sometimes becomes too much and triggers an eruption. The O'Meara's eureka moment comes in 1996 on an expedition to an erupting volcano called Arenal in Costa Rica.
Well, the coolest thing is that all volcanoes are different. They're just like people. They have different personalities. I mean, obviously there's different types of scientific volcanoes. This is a shield volcano, which has very fluid eruptions. Stratovolcanoes have huge eruptions. And volcanoes, we've actually gotten to know some, and like Arenal volcano, we call it the brat, because it's just always.
During their 2-week expedition, Arenal lives up to its nickname, erupting 15 times. They realize that the biggest eruptions occur whenever the moon is directly overhead. By tracking the moon's position over Arenal, the Omiras predict eruptions with an accuracy of 80%, a pinpoint accuracy unparalleled in the world of volcanology.
In one of them, we in fact woke the villagers and told them that, get prepared, there's going to be an eruption at 12:30, and bang, 12:30, the thing erupted right on schedule.
Since 1996, the Omiras claim to have used the moon to correctly predict eruptions all around the world.
Either I have to be the luckiest person on Earth, or the moon is affecting volcanic eruptions.
But the moon may trigger natural disasters on an even bigger scale than volcanoes. One scientist now believes the moon may have caused 2 of the worst natural disasters of recent years. The October 2005 earthquake in Pakistan and the 2004 Asian tsunami. Today, the moon is still on its journey, edging away from Earth at 1.5 inches per year. Even from 250,000 miles out in space, its gravitational pull can still affect our planet. It is suggested that the moon can trigger volcanoes, but geologist James Birkeland argues that it has a far more destructive role. He believes that the moon triggers earthquakes, quakes that kill many thousands of people. (1994), and Birkeland travels to Peru to witness that rare moment when the sun and moon perfectly line up, creating a solar eclipse.
In Peru, a large earthquake is called a terremoto, and we saw this great eclipse. And the Peruvian guide said, "I am so glad you were able to see our eclipse. We in Peru have a tradition. We watch the eclipse and then we wait for the earthquake."
This ancient Peruvian belief that solar eclipses are involved with triggering terremoto, or earthquakes, supports something Birkeland has been investigating for the past 3 decades.
They have known what I've known for 50 years almost, that the lining up of the sun, moon, and Earth often can trigger quakes.
The Earth's crust is made up of 7 tectonic plates that bump and grind against each other, creating a series of fault lines. At these points, the opposing plates scrape against each other, sometimes slipping or pushing upwards. This sudden movement causes earthquakes. Birkeland thinks that the relative position of the moon and sun above these fault lines is critical in the triggering of earthquakes.
When I saw the ocean tides due to the passage of the moon, then it occurred to me that perhaps it might loosen up the fault lines and sort of lubricate the faults and make them easier to slip.
He monitors the location of the sun and the moon during the lunar cycle as they pass over these danger zones. He also factors in how close the moon is to Earth, since the moon's orbit isn't a perfect circle, it's elliptical. The nearest point of the moon's orbit is called perigee, and its furthest is called apogee. At perigee, the moon's pull on the Earth is 20% stronger than at apogee.
Now the Earth is here, and the moon travels around the Earth in a very elliptical orbit. It's exaggerated here, but when it's at its near point, we call it perigee, it's only about 221,000 miles away from the Earth. When the moon is close, its effect on our tides is far greater than it is over here at the far point, at apogee, 253,000 miles away, just 2 weeks later.
By combining all this information, Birkeland calculates how much pressure the moon is putting on certain fault lines around the world as it passes overhead. He suggests that a new moon at perigee can actually cause unstable fault lines to slip. His technique has allowed him to predict several earthquakes in the past decade. But his theories are controversial. In 1989, Birkeland was suspended from his job as county geologist for Santa Clara, California, until he promised to stop making predictions that caused mass panic. Other scientists doubt that there is a link between the moon and earthquakes, but Birkeland claims that some of his predictions have proved to be correct. October 1989. Birkeland warns the city of San Francisco that a big quake is about to strike. A few days after his alert, during the World Series, Birkeland's tragic prediction comes true.
When the World Series quake hit, I was on the 7th floor of the county building. When, boom, the P wave hit. And for 2 seconds, I was elated. I got my quake! And then I didn't want any part of it because I was being rocked back and forth. I held onto the counter. It was frightening.
The 6.9 magnitude quake causes $6 billion of damage and claims 63 lives. It's the biggest earthquake to hit San Francisco in 80 years.
Predicting a 6.5 to 7 from the Bay Area when we hadn't had such a quake since 1906 quake is a pretty good call.
Birkeland's ideas are radical, and the exact nature of the moon's influence on earthquakes is not well understood. However, in 2004, Birkeland predicts that a huge earthquake will occur around the time of the full moon, just after Christmas. The earthquake that triggers the Indian Ocean tsunami duly occurs on December 26, 2004, at a full moon. In 2005, Birkeland predicts a 7.0 earthquake, and within weeks of his prediction, a 7.6 magnitude earthquake hits Pakistan, just after a solar eclipse over the country. Could this be a demonstration of the moon influencing our planet, even though that influence is waning? Today, the moon and sun appear exactly the same size in the sky, meaning that the moon covers the sun during a solar eclipse. But let's look into the distant future. 500 million years from now, and the moon is so far from Earth that eclipses are a thing of the past. Less than 2 billion years hence. With the moon no longer holding the Earth on its axis, the planet rocks back and forth. The weather goes wild, and life on Earth is threatened. Billions of years into the future, the moon reaches the end of its journey away from the Earth. Its orbit stabilizes. In 5 billion years, the sun expands as it nears the end of its life. The Earth and moon, so inextricably linked in life, are together in death, engulfed side by side by the awesome heat of our dying sun.
Our universe is alive with the shimmering of countless stars, but our vision from beneath the Earth's protective atmosphere shields us from the real dangers. These are the most violent objects in the universe. Bob Kirshner is a Harvard professor with a passion for the stars. he spent a lifetime studying them, from their cradle to their grave.
I remember as a kid going out and seeing stars at night, and I'd lie on the snow, I remember, with a flashlight and a star map, and try to dope out what things were where in the sky. And my mother used to call out the back door, and she'd say, "Bobby, come in, get off that snow."
Today, instead of lying in the snow, Kirshner comes to Kitt Peak Observatory.
Kitt Peak is at about 7,000 feet, so it's not a particularly high mountain, but it is considerably above the valley floor. So it's a good site for astronomy. Also, the weather is very good down here in Arizona, so we get a lot of clear nights.
He has a date with the night sky to look for one of the most dramatic and beautiful events in the universe, the birth of a new star. As the sun sets over the Arizona desert, the observatories open for work. This mountaintop gives astronomers an unrivaled view of the sky, high above the clouds and obscuring lower atmosphere. Kirshner is looking for giant clouds of gas inside our galaxy, the Milky Way, that may give birth to new stars.
Okay, we're ready. Let's go to the first one now.
All right.
There are catalogs of regions where stars have been forming or where there are big clouds of gas that people have compiled over the years. And so by looking at some of these things from the catalog, we can begin to investigate individual areas where there really are stars forming and where we can look deep into them to see what's going on.
With their high-power telescopes, Kirshner and his colleagues have been peering into enormous gas clouds inside our own galaxy. This is the Lagoon Nebula, an interstellar nursery, which is giving birth to hundreds of new stars. The clouds are mostly made of hydrogen, the most abundant element in the universe. They are so dense, they begin spiraling inwards under their own gravity. The matter collects and begins to form a fledgling star, a protostar. With a disk of gas and dust falling inwards, it spins faster and faster. This was probably how our sun and the solar system was born.
After a while, the material that is in orbit around the protostar starts bumping into itself, and so it builds up bigger particles out of smaller ones, eventually makes dust and makes gravel, and then very quickly, probably, builds up things as big as planets.
This is the moment of birth of a new star, with a new sun spawning a disk of orbiting planets.
The star shrinks down more and more until it becomes hot enough and dense enough for the nuclear reactions in the center to get going that turn it from being a glowing ball of gas into a real star, something that has a nuclear fire down in the center.
The same nuclear reactions that take place in a hydrogen bomb. Converting hydrogen into helium produces the energy that causes stars to shine. When the nuclear fires ignite, a new star is born. Since the birth of our solar system, the closest and most familiar star of all, our sun, has bathed our planet in heat and light. At the heart of the sun, 600 million tons of hydrogen are converted into helium every second in a nuclear reaction that fired up 4.5 billion years ago. For generations, the only way astronomers could study the sun's fiery atmosphere was during a total solar eclipse. For a few fleeting minutes, the sun drops its guard, allowing us a glimpse of its awesome power. Francisco Diego, a professional eclipse chaser, saw his first eclipse as a teenager in Mexico. It began a lifelong fascination with the sun.
The total solar eclipse is an event that, when you see it, you will never forget. The day of the eclipse is very special. When you look at the sun, you see this beautiful, complete, perfect disk. But the day of the eclipse, exactly at the time that has been predicted for many, many years in advance, you see how the moon starts eating into it.
At total eclipse, the moon will align itself perfectly between the sun and the Earth. The moon is 400 times closer to the Earth than the sun, and by extraordinary cosmological coincidence, it's also exactly 400 times smaller. Diego and his astronomical colleagues will travel anywhere on Earth to study this rare celestial event. Each eclipse will last just a few precious minutes.
The temperature starts dropping, and it drops up to about 10 or 15 degrees in some cases. It's very noticeable. You feel this wind, this atmosphere just agitating, and it is very, very tense moment. Then you look at the west, because the shadow of the moon is coming towards you. Very fast, at 3,000 kilometers per hour. The landscape loses its colors.
A 100-mile-wide shadow will pass over the surface of the Earth. The brightness of the midday sun will slowly turn to night.
The sky gets so dark that the corona, which is very faint, is now visible. It really flourishes. It's like a flower, a white flower that opens its petals in the sky.
This is the sun's corona, a glowing atmosphere normally obscured by the intense glare. It burns at over 1 million degrees. Giant prominences erupt from its surface. They could swallow the Earth dozens of times over. Like giant fingers, they stretch for millions of miles into the vacuum of space. But for solar astronomers like Diego, a total eclipse is over all too soon. After just a few minutes, the alignment is lost. The sun's brilliant light bursts out from behind the moon, a magical sight that eclipse watchers have named the Diamond Ring.
When you finish looking at the diamond ring and you see the shadow of the moon rushing away from you now towards the east, then you see that was it. Those 2 or 3 minutes are gone. You have been waiting for that for years, and suddenly it is gone. You feel like a vacuum, and you say, this is not enough. I want more.
As the sun breaks out from behind the moon, once again the Earth is bathed in its light. We rely on the sun's constant energy to breathe life into our planet. It gives us free energy. Its heat evaporates water to produce the clouds and rain. The slightest change in its behavior could put the world and even the human race at risk. To keep a constant vigil on the sun's enormous power from above the Earth's shimmering atmosphere, a new satellite, SOHO, was designed and built by NASA and the European Space Agency. Launched in 1995, SOHO was to promise a breakthrough in sun observations and give astronomers a front-row view of our nearest star. Douglas Goff, a solar astronomer at Cambridge University, was one of the members of the SOHO team.
The satellite has gone to a position between the Earth and the Sun, where the gravitational pull of the two cancels. So it sits there looking at the Sun continuously and beaming back the information to Earth.
The images it beamed back were beyond their wildest dreams. The sun's raging surface is a turbulent world, its eruptions ripped and torn by enormous magnetic fields. SOHO revealed that, like the Earth, the sun has weather. Gigantic solar tornadoes twist through its atmosphere. And gigantic shock waves rip across its surface. The surface of the sun is heaving. Every 5 minutes, the entire star breathes in and out. Our sun is pulsating. This is the real sound of it vibrating, speeded up thousands of times.
The outside of the Sun is in a very dynamical, turbulent motion, just like the turbulence behind the back of a jet engine. The jet engine creates a lot of noise. Similarly, this motion creates a lot of noise inside the Sun, which reverberates around and makes the Sun sing. And by listening to those tones, we can learn about the structure of the Sun inside.
Below its churning surface, there's a nuclear furnace that will burn for billions of years. From its nuclear heart, trillions and trillions of tiny particles of radiation, photons, make their arduous journey from the core to the surface. photons collide with super-dense gas. They take so many hits that a trip that should take just a few seconds takes millions of years. But after the photons escape from the surface as light, they take only 8 1/3 minutes to travel from the Sun to the Earth. Every summer, millions of people go out of their way to worship their local star. Even 93 million miles away, we can feel the Sun's enormous destructive power. But not all of us are naturally protected against the Sun's lethal rays. Fair-skinned people have weak defenses. The result is sunburn from the Sun's deadly ultraviolet radiation. This anti-burn patrol is on the lookout for unprotected bathers. The greater the exposure to the sun, the greater the risk of getting skin cancer, especially deadly malignant melanomas. Greater dangers are whipped up when the Sun's surface is twisted and contorted by powerful magnetic fields. These fields can puncture the surface and create dark areas called sunspots. Each one is big enough to swallow the entire Earth, and their presence is a warning. The magnetic disturbances cause enormous eruptions, blasting huge amounts of radiation and billions of tons of charged particles into space. Every 11 years, the sunspots increase in number and size. A mass of intense energy can head our way, engulfing the entire Earth. When this happens, it's not just the sunbathers who need to head for cover. March 1989, the sun was about to give eastern Canada an early wake-up call. It was the height of the sun's 11-year cycle, the solar maximum. Out in space, a cloud of incandescent matter over 1 million miles long was heading straight for Earth. Night workers at the National Grid Control Center had no idea what was in store. At 2:45 in the morning, engineers noticed an enormous surge in their power system. When the cloud hit the Earth, it induced a massive surge of electricity inside the power cables. Engineers struggled to reduce the load, but in a matter of minutes, they'd lost control of the whole system. Power plants over 500,000 square miles of Quebec were swamped with excess current. Moments later, the whole grid blew. The city was plummeted into darkness. Power was lost to 8 million homes. Further north, the same cloud that had plunged Quebec into darkness was lighting up the night sky in a massive celestial fireworks display. This is the Aurora Borealis. Some of the particles from the cloud had become trapped inside the Earth's magnetic field. As they passed through the atmosphere, they reacted with the air. Like a giant neon light, the solar radiation lit up the night sky. Our sun is not the only star that threatens our existence. Space is filled with harmful particles and radiation. Traveling above the Earth's protective atmosphere is extremely dangerous. Despite the dangers of traveling above the atmosphere, our desire to conquer space is so great that we are prepared to risk the consequences. In 1969, Buzz Aldrin, Neil Armstrong, and Mike Collins began their historic 250,000-mile journey to the moon.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made.
Celebrations ran high as Aldrin and Armstrong stepped onto the lunar surface for the first time. But behind the euphoria, the pair were keeping a secret from Mission Control in Houston. They'd seen more than just the dust of the moon's surface. It was only when they returned to Earth that Armstrong and Aldrin revealed their secret. They reported seeing strange white streaks of light flashing in their eyes. NASA decided to run tests on future missions to discover exactly what the light flashes might be. Astronaut Charlie Duke was their guinea pig. On board Apollo 16, he was asked to watch out for the mysterious flashes.
We're on our way to the moon, and all of a sudden I closed my eyes and I saw one. It was like the first one was like a flash bulb exploding inside your eye. It was very bright, very white, and I said, hey, I saw my first one. It was just this streak of light, very fast, and just as white as it could be, and very bright.
A young researcher, Larry Pinsky, was assigned to work with Duke and find out what was causing the flashes.
White streak in the right eye, upper center. Mark, light streak.
He recorded Duke's comments back in Houston and eventually realized the flashes could only be one thing.
Bottom to up, top. Mark, faint white dot in the left eye, extreme left.
Well, it turns out that they were seeing cosmic rays. They were seeing these elementary particles that permeate space, that penetrate the spacecraft and actually penetrate the body, and in this case, penetrate the eye.
We're feeling good. Tony, how about an extension, you guys?
What Pinsky had worked out was that Duke and the other astronauts were seeing high-energy particles produced from one of the universe's most violent acts of destruction. When a massive star trillions of miles away explodes as a supernova. As a heavyweight star nears the end of its life, it incinerates all the fuel in its core. The heavier a star is, the more catastrophic its death. The core becomes unstable. It loses energy and starts a headlong collapse that for 1 second gives off as much energy as all the stars in all the galaxies in the universe.
Cosmic rays are actually particles. They're actually little pieces of matter. They are the nuclei of atoms. The atoms come from supernovae, and they're just the bare nucleus accelerated to very, very high velocities.
I'm sure they were there all the time, but the only time you'd ever notice them is when you sort of got quiet, closed your eyes, and thought about it, and then you'd see them going off.
Mark, faint left, faint white dot in the left eye, extreme left.
There wasn't any pain associated with it. It's just sort of like a very spectacular fireworks display going off inside your eyeball.
When the astronauts returned to Earth, Pinsky took a closer look at Duke's space helmet. He found hundreds of microscopic tracks where the cosmic rays had tunneled right through.
They are tremendously penetrating and do considerable damage to the molecular structure of whatever they pass through. And this is the reason why they're a hazard to people when they pass through you.
The thought occurred to me, you know, if I was out here maybe a couple of years, these little things burning a hole through my head might cause me some problems in the future, but we didn't worry about it, of course, on a short mission like we were on.
But if a supernova is too close, it won't be only astronauts who will be at risk. It could kill everything down here on Earth. Our galaxy is packed with over 100 billion stars, many of them near the end of their natural life. At least 1 or 2 supernovas explode in our galaxy every century. 2 young astronomers from Caltech have now come up with a new theory of life on Earth that has shaken our scientific beliefs. A theory that links the death of stars to mass extinctions on Earth.
The fossil record of the last 500 million years shows 5 or 6 huge extinction events in which anywhere from 60 to 95% of species on Earth, dinosaurs, reptiles, etc., were wiped out. And so what Gautam and I really set out to do was to come up with some sort of model that would explain why the major extinctions happen when they do.
Eric Litch and Gautam Vasisht have calculated exactly when the Earth may have been close to ancient supernovas. The key to their model was understanding the rotation of the Milky Way. Like a giant spinning wheel, the Milky Way is circled by spiral arms packed with billions of stars.
Spiral arms are really disturbances that sweep through the disk of the galaxy, and gas and dust tends to accumulate along these disturbances.
Yeah, if you imagine looking at our galaxy face on, the spiral arms appear like swirls going out from the center to the outer edge, rather like the kind of whirlpool you see when water goes down a drain.
The spiral arms are where supernovas are most likely to explode. Our solar system passes in and out of the arms once every 50 million years.
We know the location of the spiral arms fairly well, so we could trace the orbit of the Earth back into time. The hope was to find a link between the times of occurrences of the extinctions and the timing of the passage of the Earth through the spiral arms.
Their calculations revealed that the biggest mass extinctions correspond exactly with the dates when the Earth had passed through the spiral arms. If a supernova exploded nearby, the surface of the Earth would have been swamped by deadly radiation.
If the solar system happens to be passing through a spiral arm, your chances of encountering a supernova explosion at close enough range to do serious damage to the Earth are quite high. In fact, we estimated something like 50-50.
Understanding the mystery of just how massive stars die has taken astronomers centuries to unravel. Modern astronomers picked up their first clues from an unusual source during the Second World War in occupied Holland. Jan Duvendak, a scholar of ancient Chinese manuscripts, discovered a document written in China nearly 900 years earlier. It reported,
"On the 22nd day of the 7th moon of the first year of the period, Chiu said, 'Prostrating myself, I have observed the appearance of a guest star in the 5th moon in the eastern heavens in Taurus. It was visible by day, like Venus. Pointy rays shot out from it on all sides.'"
The account told of a bright star that had appeared in the heavens in the summer of 1054, which shone for 22 months and then disappeared. Duvendak realized the significance of his discovery. Through contacts in the Dutch underground, he smuggled a paper through enemy lines and across the Atlantic to astronomers in the United States. "20 years earlier, American astronomers had discovered that a distant cloud of gas called the Crab Nebula at the fringes of our galaxy was expanding. By working backwards, they had calculated that it had originated from a single point some 900 years earlier, exactly the time of the Chinese star. Astronomers believed that the Crab Nebula was the debris from an exploding star, a supernova. But at the time, they had no proof. The Chinese star was so bright it could be seen in daylight, and for a time it was even possible to write by its light. What's more, the star had appeared in exactly the same part of the sky as the Crab Nebula. It clinched the argument. It had to be the remains of an exploding star. The blue glow of the Crab Nebula comes from escaping cosmic rays. The colored pincers are the remnants spewed out in the giant explosion. But for this star, the supernova explosion wasn't the end. Left behind was a strange corpse. Professor Anthony Hewish from Cambridge University discovered there was life beyond the grave for dead stars when he built an unusual telescope in the 1960s.
We started building in 1965. The thing was, we wanted a large radio telescope, which was very sensitive, but it had to be rather cheap. And I decided on this construction of a big dipole array. We all took our turns in hammering the posts into the ground and hanging up the wires and putting into the cables. It was just very much a team effort.
Over the next 2 years, Hewish and a small team of students built a jumble of wires and poles spread over a 4-acre site. This strange-looking telescope was to discover the weirdest object in the universe and win Hewish the Nobel Prize. task of running it was the responsibility of then research student Jocelyn Bell.
It was producing miles of chart paper, 96 feet of chart paper every day. And we kept scanning the sky over and over and over again. I ran it for 6 months and generated several miles of chart paper.
In August 1967, after just 1 month of operation, an unusual signal caught her eye.
As the pen ran over the chart paper, it went beep, 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 beep. Regular pulses, about 1 1/3 seconds apart.
It looks so artificial. It looks like an intelligent signal to begin with. And intelligent signals coming from outer space, what are they? Well, you make a joke and say perhaps somebody's talking to us in some kind of a code. So we call these things little green men, LGM. I mean, we didn't really believe it. On the other hand, it was a possibility you couldn't immediately ignore.
After months of analysis, Hewish and Bell came to an outstanding conclusion. Only a small, super-dense spinning object could be creating such a fast pulse. The only possibility was the collapsed core of a supernova, a neutron star. Here was the living corpse.
I really didn't know neutron stars existed until I started talking to people and said, look, can you tell me any sort of star that's smaller than 1,000 kilometers? And up came the answer, neutron stars, and maybe we're seeing the first one of them.
The pulses that come from one of these neutron stars come to us because, like a lighthouse, these stars are spinning. And they have a beam that's focused by the magnetic field of the star. And every time the beam sweeps across us, across our radio telescope, we pick up a pulse.
But for 1 year, there were literally hundreds of theories being published, and it was an absolutely open question. And I think it only became generally accepted after about 12 months that it had to be a neutron star.
The revelation triggered a wave of activity. Radio telescopes all over the world scanned the heavens looking for the mysterious pulses. Less than a year later, the giant Arecibo dish in Puerto Rico picked up a signal. It was coming from the heart of the Crab Nebula. They had found the ticking corpse at the center of the Chinese supernova. The spinning neutron star was not only giving off radio waves, amazingly, it was also visible. High-speed television pictures revealed it was flashing on and off 30 times a second. It was the most powerful object that anyone had ever photographed. Neutron stars are like nothing else in the universe. They're so dense, a thimbleful would weigh over 100 million tons.
Supposing you somehow manage to land on a neutron star, then you are experiencing phenomenal gravity. And the atmosphere, instead of being 5 miles thick, is about 5 millimeters thick. So if you stood on the neutron star, the atmosphere would be sloshing around between your toes.
But even a neutron star's phenomenal gravity is surpassed when a real super heavyweight star dies. when a star 100 times heavier than our sun switches off, it goes with a bang. While we see the outward explosion as a supernova, this masks the inward implosion. The core is collapsing into the most dangerous object in the universe. The density becomes so great in the center that gravity sucks in time and space itself from the outside universe. A darkness forms at the heart of the collapsing star. A black hole is born.
If you have a massive star, once the massive star has exhausted its nuclear fuel, which is keeping it hot and keeping it puffed up, gravity becomes so strong that it just overwhelms all pressure the material can provide, and the star goes imploding inward, and it's gone, forming a black hole.
Everyone has heard of black holes. No one has seen them or been near one. At the center of a black hole is a point called the singularity. Everything that has ever fallen into a black hole is destroyed, crushed into a pinpoint of infinite density and infinite smallness. Even space and time are squelched out of existence.
The singularity is a place where gravity is essentially infinitely strong. It's a place where matter gets destroyed. It's a place where space and time as we know them get destroyed.
At some time in the future, a spaceship from Earth will be sent into the jaws of the most elusive object in the universe. A spacecraft traveling towards a black hole wouldn't see the singularity hidden deep inside. It would only see the blackness around it. Its target has a gravitational pull that is so great, not even light can escape.
As the spaceship goes flying into the core of the black hole, I begin to feel myself being pulled from head to foot and squeezed from the sides. My body gives way, I die, the atoms of which I'm made give way, and all is destroyed in the singularity.
All that remains is a perfect sphere of absolute darkness, a gravitational ghost of the star that died. The perils of a black hole are thankfully remote. Even the nearest is over 5,000 light years from Earth. Our nemesis lies much closer to home. Like every star in the galaxy, our sun has a finite lifespan. One day, it will run out of fuel and scorch the planets. It's a terrible fate that astronomers have known for decades.
We expect that the sun will swell up in about 5 billion years, and it will become a red giant star. That's the beginning of the end for the sun.
In 5 billion years, our local star will have exhausted its fuel supply. Without fuel, the sun will die. In its death throes, the star that gave birth to life will swell and engulf the Earth and Moon. Nothing will survive.
amount of energy we'd get from the sun would increase tremendously. The Earth would heat up, the oceans would boil, eventually the mountains would melt and evaporate. The Earth would be incinerated by our own friendly star, the sun.
The heat from this red giant will be so intense, the Earth will be scorched beyond recognition.
Even in the nearby universe, we see incredibly violent examples of orbits. Giant planets that hurtle in toward their stars. We see shock waves of thousands of degrees perpetuate through the atmosphere.
There are planets that dip right over the surfaces of other stars. Huge stars orbiting each other. Multiple orbital systems where there's just chaos and entire objects can be kicked out of the system.
Stars gobbling up other stars, black holes eating up entire star systems, galaxies colliding with other galaxies. That's the norm. To create DNA out of the oceans takes hundreds of millions, perhaps even 1 billion years. And for that stability, you need circular orbits. And so without the stability of the solar system and the Earth's orbit, there's no life on Earth. Fahrenheit, hotter than a baker's oven. Also, because there's very little atmosphere on Mercury, you'd choke. And because there's no air to speak of, the blood in your body would boil and it would burst your skin. You would literally explode on the surface of Mercury.
When Pluto warms up, the frozen ices on the surface of Pluto, these are water ices, carbon dioxide, even some carbon monoxide, maybe methane ices, they evaporate and you get a fog, and the fog gets thicker, and then you get thick clouds, and suddenly you have an actual atmosphere around Pluto that wasn't there before.
As winter comes, these gases slowly begin to freeze out of the atmosphere. They may rain down in a snow-like way, but gradually they accumulate sort of a glassy, semi-transparent layer, a frozen atmosphere on the surface of Pluto. Venus is a pretty good example of what might happen to the Earth if our orbit shifted a little bit in from where we are now. Venus has this hugely thick atmosphere that traps all of the heat, and the surface is close to 900 degrees. If we moved even just a little bit closer to the Sun, we would become more like Venus.
You would have snowball Earth, the Earth completely encased in ice. And that's only by moving the Earth a fraction of its distance from the Sun. Gravity is the universal force of attraction that spreads throughout the universe itself. It's the force that holds stars together. It's the force that binds the solar system together.
An orbit is simply the motion, the path of an object around another object due to gravity. So you can have circular orbits, you can have elliptical orbits. Even if I were to take a ball and throw it in the air and catch it, very briefly, that ball is in orbit around the center of the Earth. It's just motion affected by gravity.
Things can get complicated when you have more than two objects, all trying to orbit around each other. Then, an orbit can actually loop between one object and another. Speeds can get faster and slower. An orbit doesn't have to be just one regular path.
They can start 1 trillion miles out and fall right above the surface of the sun. So when they're really far away, they're hardly moving at all. When they're whipping past the sun, they're moving really, really fast. And so these can be some of the most extreme orbits in the solar system. They can be so elongated, they're almost a straight line.
If a comet were to hit the Earth, perhaps 5-6 miles across, watch out. It would be a planet buster. It would be an object sufficient to wipe out all life as we know it on the planet.
So now we're on HD 154088. And there it is. Looks good. What we're finding among extrasolar planets is an incredible diversity of these orbital shapes and sizes. Some of the orbits are extremely tight around their host star, the planet going around in just hours or days. So we're seeing interactions and shapes and sizes of orbits that are like nothing we ever imagined.
if you had said, what's the weirdest, least likely orbit you could possibly imagine, I would have said, take something like Jupiter and plop it down right next to a star, 5 million miles away. And it turns out I would be totally wrong. That is an extremely common thing that we see in the universe. In fact, most of the planets that we're discovering around other stars appear to be in orbits like that.
Everybody's familiar with the idea of tides. In the course of a day, the level of the oceans get higher and then lower. Well, that's from the influence of the sun and the moon, from the influence of orbits, things that are going around us or that we're going around. If you bring things closer together, tides become more extreme. Planets can actually get pulled into different shapes.
The key conclusion you have to draw is when you see the universe today, it won't be that way tomorrow, and it won't be that way the week or the millennium or a billion years later because of gravity.
Planets, by definition, go around stars. So, boy, were we shocked to find rogue planets. Rogue planets are a contradiction in terms. Planets without a mother star. The presence of rogue planets shows us that gravity is not just this attractive force which binds the solar system together, it can also fling entire planets into outer space. We have two white dwarfs an infinitesimal distance apart, rotating around each other in 5.5 minutes. This is a world's record for an astronomical body in space.
A supernova is one of the most violent, energetic events in the universe today. You are blowing up a star. There's no way to describe that kind of energy.
Some supernovae are so powerful, they are second only to the Big Bang itself for energy and sheer power. They are so magnificent, they can outshine an entire galaxy of 200 billion stars.
There are few things in the universe more dramatic than a pulsar. Imagine a ball about 10 miles across, rotating hundreds of times a second. With a density that's almost unimaginable, 1 cubic centimeter of this material would have as much mass as Mount Everest.
You would feel a gravity that is millions of times what you're feeling sitting on the surface of the Earth. You wouldn't just be crushed flat by this. You would be crushed into a paste that is only a few atoms thick.
The Black Widow, in some sense, is like a vampire, sucking the lifeblood from this brown dwarf star, eating away at its hydrogen and helium fuel.
It's incredible to think of the enormous forces gravitationally that these two stars exert on each other, causing the whole geometry, the architecture of the system to change and spin around like a top on the table.
A black hole is a bottomless pit of gravity caused by the death of a star. There is nothing in the universe more mysterious than how black holes work.
If you want to talk about extreme orbits and extreme gravity, you're talking black holes. That is at the top of the list. Nothing has stronger gravity than a black hole. It is the mass of something like the sun or more compressed down into a ball that's only a couple of miles across.
Now we see them at the center of galaxies, wandering through outer space. Black holes, we now know, are central to the evolution of the universe. This configuration, a star orbiting around a black hole, is extreme and it's unstable. First of all, the black hole is eating away at the atmosphere of its companion star, but the star itself is unstable. It will one day undergo a supernova and perhaps leave a black hole in its wake. And then we'll have two black holes rotating around each other, one of the rarest sights in the universe. If you pass by the event horizon, an imaginary sphere surrounding the black hole, that's the point of no return. It's like the ultimate Roche motel. Everything checks in, nothing checks out.
A black hole has torn a star apart, swallowed up half of the material of the star, and ejected the other half in an event that is among the most violent things we have ever seen in the history of astronomy.
Any high school student knows that gravity sucks. It pulls, it never pushes. But it's actually more complicated. That's true when you just have two objects. But the minute you have more than two objects, strange things can happen, and gravity can actually push you away.
You can get very close to a body, but if you come in at just the right angle and just the right speed, instead of colliding together, one object can slingshot the other one away.
You can only eject stars at these very, very high velocities, so close to 700, 800, 1,000 kilometers a second. You could only eject these with interactions with the supermassive black hole. The interesting thing here is that you can get a complete redistribution of stars. So you have stars that are in the center of the galaxy, and suddenly they're ejected out into intergalactic space.
One of the most spectacular events in the universe is when galaxies collide. You're talking about hundreds of billions of stars, 100,000 light years across. Two of these things slamming into each other.
And you get these two galaxies that merge like two fluids mixing together, and you get long tidal tails as they pass through each other, but then gravity brings them back together again, and in the end, you get a full-fledged, more mature, larger galaxy than you had originally.
You would think a galactic collision would be incredibly destructive, and in one sense it is, but in another sense it's a very creative force.
It's incredible to think about two galaxies that gravitationally attract each other and collide. What could be more destructive? But in fact, there's a power of construction in such mergers, because as two galaxies come together, the gases are compressed, and sometimes the gases are compressed so much that you get the birth of stars and the associated planets around those stars. And so in the titanic collision between two galaxies, you can get the birth of stars and planets and perhaps eventually life on those planets.
A starburst galaxy is one that is creating stars at a much higher rate than we usually see in normal galaxies. And so it's amazing that you can have such a beautiful creative process coming out of something so violent and destructive.
When we think about scaffolding of a building, it's just sitting there static. But in fact, this scaffolding is quite dynamic and quite amazing because all of the constituents are moving around at very high speeds, crashing into one another. Galaxies, stars, black holes, supernovae, all in this tremendous cosmic dance.
Structures in the universe have evolved over billions of years through their orbits and their mutual gravitational attraction, and they've built up into larger and larger structures. And it's all thanks to these same attractive forces that bring them together, but can also tear them apart.
The atom is the basic unit of chemistry. In the same way, the orbit is the basic unit of the universe itself. If you understand all possible orbits, you understand the dynamics driving the universe.
Orbits are changeable, they're chaotic. things that we never thought were possible are in fact possible.
From the smallest scale to the largest scale, it's the gravitational interactions and collisions that actually make our universe the beautiful place that it is.
In the very near future, spaceflight will become an everyday activity. The corridors of space will become as busy as the airways of today. The environment surrounding our Earth will become the largest construction site ever. Dozens of space stations will orbit our planet. These weightless cities will launch and maintain thousands of communication satellites and provide a stepping stone for deep space exploration. A fleet of space planes will transport passengers and cargo quickly and cheaply. As more and more space planes ferry components up from Earth for use in space, we will build larger and more complex space stations, floating gateways to the universe. But the future is already here.
It's amazing what man can do.
I'm in awe.
The awesome power, the noise, the roar. You give me the chance like that.
This is our first true spaceship, returning from the ultimate journey, a 6 million mile ride around our planet.
Gs, folks. Descending through 76,000 feet at 270 indicated. Have a good HUD. 500.
It's our supreme flying machine, the Space Shuttle. The first ever machine equally at home traveling through the vacuum of space or flying through the Earth's heavy atmosphere.
50 and 250. 30. 25. 15. 10. 5. Touch. Speed brake waiting for 179. 179, arm and deploy. Shoot. Coming. You're rotating.
It has flown over 80 missions and carried over 200 astronauts into space.
Anybody who's got any sense of adventure ought to want to fly the space shuttle. The rocket ride is the best ride you'll ever get in your life. You go all the way around the world every 90 minutes. You get 16 sunrises and 16 sunsets every 24 hours.
20.
Sound suppression water system activated.
15.
Lannis's computer is now controlling.
Last check was like 3 foot C's, maybe 9.
T-minus 12. 10. 9. 8. 7. We have a go for main engine start. 5. 4. 3. 2. 1. And liftoff.
To break free from the Earth's gravity, the shuttle must use giant rockets to propel it to a speed of 17,500 miles per hour, 10 times faster than a bullet. Once in orbit, its engines must operate in an airless void where there is no lift for wings, no oxygen to burn. The shuttle has to protect its crew from the most hostile surroundings ever explored. On its return to Florida, it crashes through the skies 50 miles above Houston. It must shield them from an atmosphere whose friction would burn them to a cinder in seconds. The dream of building a space plane like the shuttle has existed almost since the earliest days of aviation. As far back as 1929, German carmaker Fritz von Opel piloted a rocket-propelled glider nearly 1 mile in a flight that lasted just 75 seconds. It was the birth of the rocket plane.
Fritz von Opel tries out the first rocket plane.
In less than 4 decades, this primitive machine would evolve into an aircraft that could take man to the outer edge of the atmosphere. By 1967, the X-15 was rocketing its pilots to a height of 300,000 feet, almost 60 miles high, halfway to orbit. Touching the very edge of space, these pioneers of aviation were almost the first astronauts. But the technology needed for a plane to leave the Earth and return safely was still out of reach. The urgency of the 60s space race demanded a far less subtle approach: massive force. In 1969, NASA celebrated its greatest triumph as it landed a manned spacecraft on the Moon. Even as its astronauts explored the lunar surface, NASA's giant rocket program was already in danger. The giant Saturn V wasn't reusable. The cost of building a new rocket for each mission was simply too great. NASA has continuously experimented with other rocket systems in a quest to find a cheap launch vehicle that could be used over and over again.
8, 7, 6, 5, 4, start check engines.
The future of spaceplanes belongs to the descendants of this, the first reusable rocket craft, the DC-XA. Operated by only a handful of technicians, this test craft is one of a number of designs that have paved the way for routine and affordable space travel. Lifting off under its own power, the DC-XA has no throwaway boosters or stages like conventional rockets. Its unique propulsion system allows it to maneuver and fly in any direction. Constructed from super lightweight materials, almost 90% of its launch weight is fuel. At the end of each flight, this remarkable machine makes a spectacular return, landing on its tail in its original takeoff position. The DCXA has provided vital information in our search for the space plane for the 21st century. Its first successor is Venture Star. Fully reusable, Venture Star will operate like a normal airplane inside the Earth's atmosphere and like a spaceship in orbit. Planned to be operational by the year 2004, Venture Star will begin a new era in commercial space transportation. Fitted with a new system of thermal protection and a new type of propulsion, it will take off and land under its own power. Each craft will have a turnaround time of only 7 days. Best of all, it will operate at 1/10 of the cost of current launch systems. Another design for the 21st century is the Mag Lifter. It's filled with people and cargo, not fuel. Present launch systems have to carry all their fuel and power with them. With the Mag Lifter, the fuel can be left on the ground. Future spaceplanes like this will use the incredible power of an electromagnetic field to help them accelerate to launch speed. But for the moment, our only operational spaceplane is the Space Shuttle. Today, there are 4 orbiters in NASA's fleet: Columbia, Discovery, Endeavour, and Atlantis. Each one can be used numerous times. They can't launch on their own, but they can glide back to Earth. NASA's shuttle fleet has flown more than 1 billion miles and has delivered more than 60% of the world's total payloads into orbit. Hundreds of tons of cargo, satellites, and communications equipment. In Earth orbit, you don't feel gravity, so shuttle astronauts can perform experiments impossible on Earth. In this unique, weightless laboratory, scientists, engineers, and doctors have learned how to handle zero gravity. But to fly to its destination in space, this vulnerable spaceplane, no bigger than a small commercial jet, must survive extremes that no aircraft in history has experienced.
Booster ignition and liftoff of Endeavour in pursuit of a Japanese satellite.
Houston, controlling. 17218, and roll program, Houston.
There has never been a flying machine that takes the pounding that the orbiter does.
A little Cessna goes from 0 to 150 miles an hour. The space shuttle goes from 0 to Mach 25. You literally sling it to about 18,000 miles an hour. There's some risk associated with that.
Okay, ready. Cabs in, visors down, CO2 on. Gonna start with the shake of your life here.
Waiting to be blasted into space, the astronauts in their small spaceplane are sitting on the most powerful rockets on Earth. When the main engines fire up, searingly hot gases explode at more than 8,000 miles per hour. They are so powerful, they create giant acoustic shock waves. The vibration caused by the noise is enough to shake the shuttle apart. To dampen these acoustic shock waves, at the exact moment the engines reach full thrust, 300,000 gallons of water are released into a trench below the shuttle. vapor cloud and exhaust fumes blow out more than 2 miles in either direction. As the shuttle accelerates, it pushes through the dense air so fast that massive stresses build up on its light aluminum frame. To prevent it from disintegrating, the main engines are throttled back until the shuttle reaches thinner air in the upper atmosphere. When the pressure reduces, the shuttle begins accelerating again, rocketing towards space at 15,000 miles per hour. After discarding its solid rocket boosters, the 3 main engines power the shuttle the remaining 50 miles into orbit.
Endeavour Houston, go with throttle up.
Roger, go throttle.
Once the external liquid fuel tank is jettisoned, this fragile machine and its crew have survived the first leg of a fantastic journey.
Welcome to space, guys. Thank you.
Time on orbit is very expensive, and so your day is packed. But if you do get a little spare time, what came to me anyway is I'm looking down on the Earth and I'm looking out the window at this black void of space and the harsh environment that we're in. What I hear in the background is the cabin fans of the vehicle. Everything is just running smoothly, and I'm thinking, what a fantastic spaceship to work so well. You don't think about what it's protecting you from.
In order to survive the extreme conditions of space, a spaceplane must create a microenvironment in which both humans and machinery can function. As the astronauts go about their tasks, a life support system automatically provides everything they need to survive. Onboard filters and air conditioners control temperature, humidity, and air pressure. An atmosphere identical to that on the Earth is produced and completely replaced every 7 minutes. The orbiter must also power its huge banks of electronics and computers. Over a 2-week mission, onboard hydrogen fuel cells generate as much energy as 10,000 car batteries. A byproduct of these mini power stations is large quantities of pure water. The crew drinks some of the water, but the rest has to be jettisoned. It spews harmlessly out into the freezing vacuum of space, where it drifts away as tiny particles of ice. The shuttle must also carry the power to maneuver itself in this weightless environment. It is equipped with 44 small thruster rockets in clusters around the nose and tail. They produce tiny amounts of thrust, but in space there is no friction, no resistance. This small ejection of gas is enough to give the shuttle a powerful kick. But this propulsion system is also highly sensitive. Firing its thrusters in short bursts, the shuttle can move forward or backward and turn 1 inch at a time.
Current distance is 104 feet.
This remarkable precision enabled the shuttle to rendezvous and connect with the giant Russian Mir space station as they both sped over the Earth at 18,000 miles per hour. This spectacular meeting was not just a publicity stunt. It moved us one step closer to the building of the next generation of space stations, in which we will live and work. But this wasn't the only instance when the shuttle's intricate docking abilities have been put to the test. Its most spectacular mission was as a breakdown truck to capture and repair the stricken Hubble Space Telescope. Once it has completed its mission in orbit, the shuttle must survive its toughest test, a return journey of over 12,000 miles in less than 1 hour. To begin its perilous journey back home, the shuttle first must slow down. With one large burst of thrust, the shuttle drops into a lower orbit. It's on its way home. With no engines to regain height, there's no turning back. The shuttle is positioned nose up, ready for re-entry. The crew has just 30 minutes before they hit the upper atmosphere and encounter a wall of fire.
What the orbiter has to go through is unlike anything that's asked of any other flying machine.
Your feet are literally in the pilot's seat a few inches, or not much more, from 3,000 degrees or close to it.
It's like trying to fly a normal airplane through the middle of a volcano and have it come out of the other side in one piece.
Ever since the beginning of manned spaceflight, the danger of re-entry has been a constant problem. The underside of early capsules used in the Mercury and Apollo programs were covered in a thick, heat-resistant resin. This protective layer was designed to burn and break away, providing just enough protection for the crew to survive re-entry. But for a reusable spaceplane to be a success, we need a reusable heat shield. For the shuttles to survive up to 100 re-entries, they're covered in a layer called the thermal protection system. Early wind tunnel tests showed that during re-entry, the temperature would vary enormously across the orbiter's surfaces, requiring a different type of protection for each area. Captured by infrared cameras during a night landing, the nose cone and leading edges of the wings were seen to glow at temperatures hotter than molten lava. To resist these extremes, these surfaces are made of a solid block of reinforced carbon, capable of withstanding temperatures of 3,000 degrees. The upper surfaces of the fuselage don't experience such high temperatures. They're covered in soft cloth blankets made from 90% glass. Handmade in a sewing shop at NASA, over 2,000 blankets are used on each orbiter. But it's the belly of the shuttle that is the largest area in need of special protection, provided by over 25,000 silica tiles. No two tiles are alike. Each one is designed and measured to fit exactly the contour of the shuttle skin. One by one, the tiles are painstakingly glued into position. This special silicon-based adhesive remains flexible from 0 to 3,000 degrees. If it became too brittle, the tiles would break off. These tiles are so efficient at removing heat that they can be taken from an oven at 2,000 degrees and held by bare hands after only a few seconds. In the first shuttle flight, a few of these tiles fell off. It caused some damage, but the shuttle got safely back to Earth. Each tile weighs just a few ounces and has a soft, foam-like structure inside. This fragile outer skin of tiles and blankets is all the shuttle has to protect it through its fiery return to Earth. The shuttle drops from a height of 120 miles down to 75 miles, where it slams into the atmosphere at nearly 16,000 miles per hour. The crew is strapped into their seats, in pressurized suits, just in case anything goes wrong. Outside, just a few feet away, their machine begins to take the ultimate punishment. As the space plane screams down into the thicker atmosphere, it collides with trillions and trillions of tiny gas molecules. It hits them so hard that it creates a glowing plasma of electrically charged gas particles around the shuttle.
And I can see the plasma just building and collapsing in a bright white flash down the middle of the vehicle. This plasma is crazy. It's like little pieces of vehicle flying off in front of us there.
Within the plasma, the shuttle is traveling in a fireball as hot as the surface of the sun. To survive re-entry, the orbiter must slow down even more. It utilizes the drag of the upper atmosphere to reduce its speed by flying a series of giant S-shaped turns. 20 minutes from touchdown, the friction on the shuttle's skin reaches maximum, scorching the protective tiles to 3,000 degrees Fahrenheit. When it finally emerges from its fiery cocoon, the shuttle is on the final leg of its journey. Still over 500 miles from the runway, it will cover this distance in less than 10 minutes.
G's, folks. Descending through 76,000 feet at 270 indicated. Have a good HUD.
As the shuttle's computers sense an increase in external air pressure, they transfer flight control from the thrusters to the wings. As the wings bite into the dense air, the space plane becomes an airplane.
45,000 feet. Range 23 miles.
Without any power from its engines, the orbiter glides to Earth at 3,000 miles per hour. It's still traveling faster than the speed of sound, and 2 sonic booms are triggered by shock waves from the nose and wings.
Central Florida got a wake-up call. Approach and land.
The shuttle is descending 20 times faster than a conventional aircraft. Five minutes before touchdown, the commander takes over from the computers. They train for hundreds of hours for this single moment.
5 minutes. Copy.
The orbiter hits the runway at over 200 miles per hour. The space plane has returned home. The shuttle program is by far NASA's longest commitment to manned flight. It is the world's most successful spacecraft, but the road to orbit was far from smooth. Four years after the last astronauts left the moon, NASA unveiled the space shuttle. "10 years of design and 2 years of construction had gone into building it, and it had cost $20 billion. This was the first space vehicle designed to carry both a crew and a payload into orbit and fly back again. NASA hoped the shuttle would change space exploration forever, It did. The shuttle's unique design combined 3 systems in one to ensure maximum reusability. First was a delta-winged spaceplane, the Orbiter. With built-in rocket engines, it could carry a maximum of 8 crew and over 30 tons of cargo. The Orbiter weighs 100 tons and is the same length as a DC-9 airplane. The second component of the shuttle system was a giant external liquid fuel tank. Containing 500,000 gallons of liquid propellant to feed the Orbiter's engines, this fuel tank would be the only component of the shuttle that would be destroyed during launch. But the Orbiter's engines weren't sufficiently powerful to launch this monster into space on their own. It needed the third system, a pair of solid rocket boosters, mounted either side of the liquid fuel tank. Their enormous thrust would lift the entire 2,000-ton package off the launch pad. These 3 elements had never been tested together. The shuttle's first flight could be its last. It was crewed by 2 men, Commander John Young, NASA's most experienced astronaut, and first-time space flyer Bob Crippen. On April 12, 1981, the world held its breath for the maiden voyage of Space Shuttle Columbia. This was to be the first time a new launch vehicle had been tested with men on board.
Toward the White Room, in which they will be prepared for entry into the orbiter. T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start. Liftoff of America's first space shuttle. And the shuttle has cleared the tower.
Speeding into space, Columbia carried the hopes for the space program. The shuttle was to prove so successful that even America's biggest rival in space decided to copy it. This is the Soviet shuttle. Its name is Buran, meaning blizzard. Buran was developed in the early 1980s to give the USSR its own spaceplane. It contained design concepts almost identical to NASA's shuttle. Its designers later admitted borrowing the American blueprints. Buran was designed to be launched simply as a payload. It's strapped to the side of the world's most powerful rocket, the giant Energie. In 1988, Buran made its first and only flight. After completing this faultless test flight in 3 hours, Buran touched down to the cheers of the Soviet Space Administration. Unmanned, Buran had orbited twice around the world. Its whole mission had been entirely controlled by computers. With the breakup of the Soviet Union and a cash-strapped Russian economy, the project has been shelved. Once the pride of its space program, Russia's spaceplane Buran is going nowhere. But it had proved that computers, as well as astronauts, can command the world's future spaceplanes.
When I first started flying, it was sticks and cables and pulleys and things, and then you get to this thing and you're totally dependent upon the computers, and so you just have to put your trust and confidence in them. You have to. You have no choice. I mean, everything depends on those computers.
Launch day, and another flight of NASA's spaceplane is about to begin. As the liftoff approaches, 3 miles away in a reinforced bunker called the firing room, more than 300 engineers and technicians are preparing themselves for the most critical moment of the mission.
The orbiter is literally loaded with liquid oxygen and hydrogen potential explosions, and it's an extremely dynamic situation for us. There are hundreds and hundreds of things that must be monitored, hundreds of things that could go wrong. We have to know extensive information about each and every system on board.
With 20 seconds remaining to liftoff, the launch becomes too complex for humans to handle.
T-minus 15 seconds. 12, 11, 10, 9, 8. We have a go for engine start. 3.
As it fires its main engines, deep in the bowels of the world's most complex machine, the shuttle's computers make over 4 million decisions every second. The destiny of the crew is totally dependent on whether those decisions are right or wrong.
Booster ignition and liftoff of Endeavour in pursuit of a Japanese satellite.
Roger, roll, Endeavour.
The shuttle is designed to operate at the very limits of performance. Without its computers, this highly unstable spaceplane would lose control in seconds and crash. Computers must fly it from launch to landing with absolute precision. Although well over 20 years old, the shuttle's computer systems are even now unequaled in complexity and reliability. Each orbiter carries 5 identical computers. They're responsible for the simultaneous control of millions of components.
One of the most remarkable things about the shuttle is that in addition to monitoring all of the systems on board the shuttle for normal operation, simultaneously it has to consider literally an infinite number of scenarios that might occur in the face of failures or unexpected events, and take the right action with split-second accuracy for every one of those situations. It has to do it right every time because you don't get a second chance.
During every moment of the orbiter's journey, over 10 million sensors and instruments located throughout its structure are feeding its computers vital flight information along 2,000 miles of wires. Ruthlessly searching for errors, any problems they detect are dealt with in a most unusual fashion. Like an electronic jury, its computers discuss the problem, then vote for the best solution. The computers collaborate and solve life-threatening problems before the crew even know they exist.
25. Standing by to activate the sound suppression water system.
15.
T-minus 10, 9, 8, 7. Go for main engine start. 3 main engines up and burning. 3. We have a cutoff.
In over 80 flights, there have been only 5 aborted launches, where the computers shut off the main engines with less than 3 seconds to lift off.
No MPS fire detectors tripped.
Orbiter access arm now back in position. Discovery is now in the safe configuration. Crew is in no danger.
The computers have worked perfectly every time. Successful space exploration depends upon an obsession with safety.
There is no error that's acceptable. There's no room for error. There's no opportunity for failure that we can allow with the software on shuttle missions. Human lives depend on it.
The hands those lives depend on are those of more than 300 specialist programmers who spend 3 years creating instructions unique to each mission. Symbol by symbol, character by character, these programmers write more than 420,000 lines of numbers and letters that will control the shuttle during every second of its mission. They are creating an electronic brain. With the lives of the crew at stake, there is no room for error. to make sure it's foolproof. The code is put through the most rigorous testing process in the world. Creating every problem imaginable, the entire mission is rehearsed by the computers more than 10 times before it even takes place.
We have a go for engine start. 5, 4, 3, 2. Booster ignition and liftoff.
But once the computers have ignited the solid rocket boosters, there's no turning back. No other machine on Earth possesses quite so much muscle. In order to lift off, the space shuttle uses 2 systems of propulsion, its twin solid rocket boosters and 3 liquid rocket engines located in the orbiter. Designed to last for 55 flights, the 3 main engines built into the orbiter are the only reusable liquid rockets ever built. Compact and lightweight, they are the most powerful and sophisticated rocket engines of their size.
Pound for pound, these engines are extremely powerful. Of course, they need to be powerful if you're going to kick an orbiter into low Earth orbit in 8.5 minutes.
Fueled by a mixture of liquid hydrogen and liquid oxygen, each engine develops over 12 million horsepower, more power than 64,000 V8 car engines. To achieve this power, they must operate at extremes of temperature and pressure.
When we ignite this engine, what you're seeing is probably one of the most dramatic cold starts of any engine in the world.
Prior to ignition, this engine is literally frozen by liquid hydrogen. As the engine fires, its temperature instantly jumps from below 0 to 6,000 degrees, and it reaches full power in just 1/1000th of a second. But these rockets provide only 1/4 of the shuttle's total thrust. Just feet away from the astronaut's cabin are the most powerful rockets in the world, the solid rocket boosters. Standing as high as the Washington Monument, they are loaded with 500 tons of dry rocket fuel. In less than 2 minutes, they rocket the shuttle to an altitude of 30 miles at 9 times the speed of sound. But the amazing power of solid rockets has one disadvantage. Once started, they can't be stopped, as the crew of Challenger discovered on January 28, 1986.
21 seconds. Solid rocket.
It was the worst accident in NASA's history.
9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Controls, 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles. Downrange distance 3 nautical miles. Engines throttling up. 3 engines now at 104%.
Challenger, go at throttle up. Challenger, go at throttle up.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
Man's finest machine had failed. But how?
Flight GC, we've had negative contact, lost downlink.
Soon after liftoff, the right solid rocket booster developed a serious leak of red-hot gases from its lower joint. A bright flame can be seen licking the side of its external tank. As the flight continued, the gases burned away the booster's lower strut, eventually causing it to tilt into and puncture the external tank. 500,000 gallons of hydrogen ignited in a giant fireball. But it wasn't the explosion that killed the Challenger crew. The tiny compartment containing the crew remained intact, clearly visible as it plummeted to the ocean beneath. Many experts believe that inside, some of the crew were still conscious until the fatal impact with the water, over 2 minutes later. NASA recovered slowly from the tragedy. After taking the remaining fleet out of service for 2 years, it redesigned the solid boosters and developed new escape systems and safety drills. In more than 50 missions since Challenger's tragic loss, there have been no further problems. But man's most amazing machine still has one major problem. It's getting old and out of date.
The shuttle is a beautiful machine. It does everything we ask it to do, but it was designed in the 70s and has old technology and is very expensive. It's got an external tank that we throw away every time. It's got solid rocket motors that need to be refurbed every time. It takes a lot of people, a lot of infrastructure to go do that.
As we move toward the year 2000, our current generation of space planes faces a serious problem. They consume huge amounts of money. They are pricing themselves out of business. Maintaining NASA's fleet of 4 shuttles requires the full-time attention of nearly 30,000 people. It costs several $100 million to send each astronaut into space. The cost of just one launch has been estimated at $1 billion. So the race is on to design and build a far more cost-effective launch system. The need to have a fleet of commercial spaceplanes is greater than ever before. As we consume and demand more and more information, faster and cheaper spaceplanes are needed to deliver thousands of satellites into orbit. A new breed of spaceplane is already on the way. The Japanese space agency, NASDA, is developing a small spaceplane called HOPE. Designed to ferry astronauts and cargo to the International Space Station, HOPE could be in operation early next century. The French have a different concept. Named Hermes, their spaceplane is designed to be launched on top of an Ariane 5 rocket. Carrying up to 4 tons in payload, Hermes will carry astronauts and materials to and from the International Space Station. The future is within our grasp.
What we're trying to do is take advantage of technology and have a vehicle that flies more like an airplane, that you take off and land, you don't have to throw things away, you don't have to refurb it as much. It takes advantage of things that we've learned for the last 25 years. If we do that, we can have greater access to space, explore the universe, and do some really great science.
In the foreseeable future, spaceplanes will be a part of everyday life. But what will their destinations be? Some will literally be super-fast transporters to other countries. Traveling at a height of 70 miles, spaceplane passengers will fly from New York to Tokyo in 30 minutes. Others will dock at the International Space Station, already under construction. As fleets of spaceplanes bring equipment and materials from Earth, we will build new space stations for future travelers. Ordinary citizens will travel to luxury hotels and orbiting universities. When the problems of prolonged weightlessness on the human body have been solved, a new breed of spacefarers will commute daily into orbit. A later generation of spaceplanes will even allow us to voyage to manned bases on the moon. And one day, spaceplanes will provide the springboard for deep space exploration. Man's most extreme machine will have turned his most extreme dreams into reality.